Hey everyone, in this video we're going to go over section 4.2, multiplication of polynomials. Our main objectives are going to be figuring out how to multiply any two polynomials together. We're going to talk about the FOIL method. It's really just a distributive property. We're going to use a rule to square a binomial, and we're going to use a different rule to multiply a sum and a difference of the same two terms. And finally we're going to be working with function notation. So let's begin with multiplying together some monomials. So, for our first example, let's say we wanted to multiply 10x squared and 8x to the fifth. Well, straight out of the gate, we're just multiplying monomials together. We have no addition or subtraction to speak of. This problem is just multiplication. And something that might help us along the way is we can remember when we're multiplying variables, or when we're multiplying two factors with the same base, say x to the n times x to the m, well, when we multiply two factors with the same base, their product has the same base and we add their exponents. So that's what we're going to do over here. First, we can multiply our constant terms together. 10 times 8 gives us 80. And using this rule over here, we've got an x squared and an x to the fifth. That would give us x to the 2 plus 5, or give us 80x to the seventh for our final answer. Monomials are pretty quick and easy. When they have different variables, they might get a little bit tricky. Like if we had negative 8x to the fourth times y to the seventh, all of that times 5x cubed y squared. Draw a line to separate these two examples. So, first we notice there's no addition or subtraction in this problem. That means we can go straight ahead with multiplying. We're going to multiply our constant terms together, or our coefficients is a better way of saying it. So negative 8 times 5 will give us a negative 40. Now we're going to have an x to the 4 plus 3, and then a y to the 7 plus 2. We'll simplify that. Negative 40, x to the 4 plus 3 is 7, y to the 9th for our final answer. When we're multiplying monomials together, it's really just gathering like terms with multiplication. Your variables will add our exponents. You only add exponents of common variables, so when they have the same base. That's why the 4 and the 3 went together, and the 7 and the 2. But monomials are straightforward. You multiply straight across. It starts to get tricky when we have a monomial and a binomial. By that I mean something like 2x times 3x minus 5. Now if you look, we have multiplication. We've got multiplication right here. And we have subtraction. Right there. When we have two different operations, like multiplication and subtraction, or multiplication and addition, this is when we're going to want to use the distributive property. In fact, this entire lecture is pretty much about the distributive property. So, what we want to do is we want to take the 2x, 3x minus 5. And what we want to do is we want to take the 2x and we're going to multiply it in to the 3x, and we're going to multiply it in to the 5. So 2x times 3x will give us a 6x squared. We're going to keep this minus sign, minus 2x times 5 will give us 10x. Another monomial times a binomial. Let's consider 3 a squared b times a squared minus b squared. So just like in the problem above, we want to take this leading factor and we want to multiply it in to each of these terms. So first, we have 3a squared b. Well, a 3a squared b times a squared, that would give us 3a to the fourth, because we have 2 over here and 2 over here, and that b is just along for the ride. Then this minus sign is going to drop down, and we'll get a 3a squared b times a b squared. The 3a squared isn't going to change, and now we're going to combine like terms. B times b squared gives us b cubed. Well, we started off multiplying two monomials together. We jumped up to multiplying a monomial and a binomial. So let's take it one step further and multiply two binomials together. Let's say we wanted to multiply 3y squared plus 4 times y squared minus 2. So we'll talk about FOIL in a couple examples. I want to show you a different method you can use for multiplying these two binomials together. Kind of like how if we wanted to multiply, say, 14 times 3, we could put 14 on top and 3 on bottom, draw a line, and we'd multiply. 4 times 3 gives us 12. 3 times 1 is 3 plus 1 gives us 4. Well, we're going to do something that looks similar to this with these binomials. We want to multiply 3y squared plus 4, and we want to multiply that by y squared minus 2. And we'll go through, and we want to multiply these binomials. Well, negative 2 times 4 gives us a negative 8. Negative 2 times 3y squared gives us a negative 6y squared. And now, down here, let's say we wanted to multiply 14 by 12 instead of by 3. That'll illustrate what I want it to do a little more. 2 times 4 gave us 8. 2 times 1 gave us 2. Then we drop down and we write a 0. 1 times 4 is 4. 1 times 1 is 1. Then we add, and our final number was 168. What I wanted to show you was how we put a 0 there. We're also going to put a 0 right here. So then we continue with multiplying. Y squared times 4 would give us a plus 4y squared. Then y squared times 3y squared would give us a plus 3y to the fourth. And now we're going to go through and we're going to add. 3y to the fourth is going to drop down. If we have a negative 6y squared and a positive 4y squared, that would give us minus 2y squared. And negative 8 take away 0, plus 0 is still a negative 8 for our final answer. So let's do another example using this method. Let's say we wanted to multiply p plus 2 times p to the fourth minus 2p cubed plus 3. Well, we're going to set this problem up just like we did over here. We'll put p to the fourth minus 2p cubed plus 3 on top of p plus 2. And we'll draw our line. So we multiply 2 times 3 to give us 6. 2 times negative 2p cubed to give us a negative 4p cubed. And then 2 times p to the fourth gave us a 2p to the fourth. 2 times 3 gave us a positive 6. We'll go through and we'll put a 0 just like we would with normal multiplication because we're moving to this column. And we multiply. P times 3 gives us a plus 3p. P times negative 2p cubed will give us a negative 2p to the fourth. And then p times p to the fourth would give us plus a p to the fifth. Now we want to go through and we want to add. And be careful, we want to add like terms. We've got a 6 plus 0, so we get a 6. Now, we have just a 3p floating around. We don't have any other 3p's, so we'll get a plus 3p. We don't have any p squareds floating around, so we would next jump to p cubes, and we have negative 4p cubes. We have a positive p to the fourth and a negative p to the fourth. Those are going to cancel each other out, and we're left with p to the fifth for our final answer. So let's do a final example with this method. Let's say we wanted to multiply a 5x cubed plus a 3x squared plus x minus 4, to which we want to multiply it by a negative 2x squared plus 3x plus 6. So, just like before, we'll write 5x cubed plus 3x squared plus x minus 4 on top of a negative 2x squared plus 3x plus 6. And we want to multiply. So 6 times 4 gives us a 6 times negative 4 is a negative 24. 6 times x is a positive 6x. 6 times 3x squared gives us a positive 18x squared. And then 6 times 5x cubed gives us a positive 30x cubed. We're then going to write a 0, move over. 3x times negative 4 gives us a negative 12x. 3x times x gives us a positive 3x squared. 3x times 3x squared gives us a positive 9x cubed. And then finally 3x times 15x cubed will give us a positive 15x to the fourth. Okay, now we put 1, 2 zeros. Negative 2x squared times negative 4 gives us a positive 8x squared. Negative 2x squared times x will give us a negative 2x cubed. Negative 2x squared times 3x squared will give us a negative 6x to the fourth. And finally, negative 2x squared times 5x cubed will give us a negative 10x to the fifth. Oops, ran out of space over there. Now what we're going to do, go through and add these columns. We'd get a negative 24. We'd get a 6x take away 12x is a negative 6x. 18, 19, 20, 21 plus 8 is 29, so plus 29x squared. 30 plus 9 is 39, take away 2 will give us a positive 37x cubed. 15 take away 6 would leave us with 9x to the fourth, and finally minus 10x to the fifth. Need a plus sign right there. So our final answer, 5x cubed, or the quantity of 5x cubed plus 3x squared plus x minus 4 times the quantity of negative 2x squared plus 3x plus 6 is equal to negative 10x to the fifth plus 9x to the fourth plus 37x cubed plus 29x squared minus 6x minus 24. My biggest advice for you guys when you're multiplying polynomials together is just go slow. These things are going to get pretty big, and try and not squeeze your work into one space. Try and leave you enough space so you can think about the problem so you don't get cramped. It's when you get cramped and you try and squeeze things in that you guys are going to start to make mistakes. It's just human nature. So don't worry about large polynomials, and don't be surprised if these take up a little bit of space on your paper. So let's talk about a different method for multiplying. Really, we're going to use it to multiply binomials together, but it can be expanded to multiply any polynomials together. This method we're going to talk about is FOIL. FOIL is really an acronym that's going to help us to remember to use the distributive property, with binomials. So FOIL stands for first, outside, inside, and last. And what that means is, let's say we had the following binomial, x plus 5 and x minus 8. What FOIL stands for is we want to multiply the terms that come first. So we'll take the first of the two. First, x times x is equal to an x squared. Then for outside, we want to use we're going to multiply the two terms on the outside together. So x times negative 8 will give us a negative 8x. Then inside, we want to multiply the inside terms together. 5 times x will give us a positive 5x. And last, we want to multiply the final terms together. 5 times negative 8 gives us a negative 40. Our final step is to gather like terms. So we've got an x squared. We had an 8x, a negative 8x, and we gained 5 x's. That gives us a negative 3x. And we still have a minus 40 floating around on the end. So FOIL is just the distributive property. We've got a nice acronym. I have actually taught this lecture or this lesson in Spanish before, and FOIL doesn't work in different languages. So don't be surprised if you're going through your studies, you get out of my math class, you're working with some students in your other classes, and they have never heard FOIL before. It only really exists in our language. Just an acronym for the distributive property. And when we're using the distributive property, something to notice, I forgot to draw my arrows, is that every term of the first polynomial, in this case a binomial, is going to get multiplied with every term of the second polynomial. We multiplied an x times an x, and we multiplied an x times a negative 8. Then we multiplied a 5 times an x and a 5 times a negative 8. We could have used this process back here, and we would have done 5x cubed times negative 2x squared, 5x cubed times 3x, 5x cubed times 6, then we'd move down. 3x squared times negative 2x squared, 3x squared times 6x, 3x squared times 6, x times negative 2x squared, x times 3x, x times 6, negative 4 times negative 2x squared, negative 4 times 3x, negative 4 times 6. We're using the distributive property to kind of guide us in multiplying every term of the first polynomial by every term of the second polynomial. But like I said, it's just the distributive property. So let's use FOIL. Let's do something a little bit better. Let's multiply 3xy plus 2x times an x squared plus 2xy squared. And so we're not gonna arrange these on the two columns. We're going to use FOIL. We'll multiply first our first terms, or the terms that come first in each of these binomials. 3xy times an x squared would give us a 3x cubed y. Then outside, up and over, we have a 3xy times a 2xy squared. 3 times 3 will give us a positive 6. X times x will give us an x squared. And y times y squared will give us a y cubed. Then we do inside. 2x times x squared would give us a positive 2x cubed. And finally, our last. 2x times 2xy squared would give us a positive 4x squared y squared. And now let's take a look. We want to combine like terms if at all possible. We've got an x cubed y. I don't see any other x cubed y. We've got an x squared y cubed, an x cubed, and an x squared y squared. Perfect. Can't gather any like terms. And you can add in any order you want to, so I wouldn't worry too terribly much about rearranging these terms. It would be convenient to arrange them with the powers of y decreasing. We've got a y cubed, a y squared, a y to the 1, and a y to the 0. But like I said, you can add in any order you want to, so you can rearrange that as much as you wanted to, and you wouldn't change the answer any. So let's move on to the square of a binomial. And what do I mean by that? Well, let's say we had something like a minus b squared. Well, a minus b squared, remember what that exponent means. That means we've got an a minus a b times another a minus a b. And now we can use FOIL, we can use a distributive property on this. A times a would give us an a squared. A times negative b gives us a negative a b. Negative b times a gives us another negative a b. And then negative b times negative b gives us a positive b squared. We go through and gather like terms. We have a squared minus 2ab plus b squared. So, how can we use this formula? A minus b squared is equal to a squared minus 2ab plus b squared. How can we use that formula to solve stuff like y minus 5 squared? Well, if you look, in this problem, y is acting like a, and b is acting like 5. And if you look, we need an a squared, we need a negative 2ab, and we need a b squared. Well, if a is equal to y, that would tell us that a squared is equal to y squared. So this is going to be equal to a y squared. Now we have a negative 2. That part sticks around. A times b. Well, a is y and b is 5. And finally, we're going to add b squared. Well, if b is equal to 5, that tells us that b squared is equal to 5 squared, or 25. The final step is to gather like terms, and I kind of got in my own way. That's going to be equal to a y squared. Negative 2 times 5 gives us a negative 10y plus 25. Or, what if we had something like a plus b squared? Well, we're going to expand it just like we did up here. That's the same as a plus b times a plus b. Using FOIL again, we'll do our first. A times a gives us a squared. Outside is plus a times b. Inside is plus a times b. And last is plus b squared. Or if we simplify, that would give us an a squared plus 2ab plus b squared. So, if we want to use this formula to solve something like, let's say 2x plus 3y squared. Well, we have 2x acting as a. So if 2x is equal to a, if we square both sides, that would say 4x squared is equal to a squared. And we have a 3y acting like b. If 3y is equal to b, that would mean that 9y squared is equal to b squared. Now we have all the pieces that we need to fill out our formula. This would be equal to, and I'm going to draw my equal sign kind of obnoxiously long and start writing over here. A squared is going to be a 4x squared plus 2 times a, which is a 2x, times a b, which is a 3y, plus b squared, which is 9y squared. Last thing we're going to do is simplify this a little bit. 4x squared plus 2 times 3 is 6 times 2 is 12 xy plus 9y squared for our final answer. So using these, the book calls it a rule. You do not necessarily need to go through and use this rule. Expand it to a squared minus 2ab plus b squared, and then put the pieces where they go. You can solve both of these problems, and I'll work down here, running out of space. Well, if I'm running out of space, I can work over here. You could take y minus 5 squared, and then write it as y minus 5 times y minus 5, and you can use your distributive property. First, outside, inside, last, to get y squared minus 10y plus 25. Same answer we got over here. In this lecture, we're working on pushing together polynomials. We're using the distributive property to take two polynomials and turn them into one. Next lecture, we're going to be factoring. So we're going to be taking larger polynomials and we're going to be breaking them up into two smaller polynomials. The reason why you should practice this method is because going forwards is easier than going back. It's easier to multiply two polynomials together to get a polynomial than it is to factor a polynomial into two smaller polynomials. So by doing this method, you'll start to recognize some patterns. And that'll help you in the next lecture, and it'll also help you in the test we'll eventually take over this sort of material. So even though this method might be easier, I would encourage you to try this method at least once or twice. You don't have to do your entire assignment with this method, but try this once or twice to get an idea how different binomials behave when you multiply them together. The final rule we're going to talk about is a plus b times an a minus b. We're going to use our distributive property, so we're going to multiply the first, a squared, times the outside of, minus a b times the inside, plus a b times the outside, negative b squared. When we go through and gather like terms, we've got this negative ab and a positive ab. They're going to cancel each other out, and we're left with an a squared minus a b squared. And so this is our new rule. We see that a plus b times a minus b is equal to a squared minus b squared. So if we wanted to multiply y plus 5 times y minus 5, well, we see that y is acting like a, so we get that y is equal to a. We square both sides, that means a squared is equal to y squared, and b is acting as 5, so we get 5 is equal to b. When we go through and square both sides, that says 25 is equal to b squared. So we've got all the pieces that we need. We know that y plus 5 times y minus 5 is going to be equal to a squared, or y squared, minus b squared, which is 25. So we really have these three rules, and I'll give you a couple more examples of these. Something I want to say before I forget, though, be very careful, because it is true that a times b squared is equal to a squared b squared. That's fine. That's totally acceptable, because a times b squared is equal to a times b times a times b. You can multiply in any order you want to, so I'm going to first I'm going to multiply a times a to give us an a squared, then I'm going to multiply b times b to give us a b squared. That checks out. But a plus b squared is not a squared plus b squared. Similarly, a minus b squared is not a squared minus b squared. We have it right over here. A minus b squared is actually equal to a squared minus 2ab plus b squared, and a plus b, that's actually equal to a squared plus 2ab plus b squared. Wanted to point this out. Students make this mistake all the time. I've seen this mistake in every section of calculus I have ever taught. Students really want to say that that is equal to that. But remember, if you've got a binomial squared, you need to use the distributive property. So don't tell me that a plus b squared is a squared plus b squared, or that a minus b squared is a squared minus b squared. You guys need to use FOIL, just like we did up here, to get your correct answer. But let's use that new rule. A plus b times a minus b being equal to a squared minus b squared. Let's use this rule to solve a problem, and let's introduce some fractions. Let's say we had 2/3 of an a minus b squared times 2/3 of an a plus b squared. We've got a's up here and a's down here, so I'm just going to rewrite this problem to help us from getting confused. And I'm going to call it 2/3 of an n minus m squared times 2/3 of an n plus m squared. There we go. That would have gotten a little confusing. So we have an a plus b and an a minus b. We have an a plus b times an a minus b. Remember, you can multiply in any order you want to, so it doesn't matter if the plus comes first or second. And we see that in order to solve this problem, we need to figure out what an a squared is and a b squared is. Well, this 2/3 of an n is acting like an a, so if we go through and square both sides, we get 4/9 of an n squared is equal to an a squared. Because remember, if we had an a over b to the n, that's equal to a to the n over b to the n. Similarly, we have b being m squared in this problem. So when we go through and square both sides, we get b squared is equal to m to the 4th. Well, since we know that a minus b times a plus b is a squared minus b squared, that means 2/3 of an n minus m squared times 2/3 of an n plus m squared has to be equal to 4/9 of an n squared minus m to the 4th. Once again, we could have gone through and used our distributive property. Students tend to like formulas that they can apply to situations. If you don't remember anything else from this lecture, remember that you use the distributive property to multiply polynomials together. You don't need to have this memorized, and you don't necessarily need to have, these two memorized. They will help you if you like formulas. If you don't like formulas and you like a process, the process that we're doing is just the distributive property. It's all we've done this entire lecture. Perfect. So let's move on to, well, let's do one more. I want to show you that these can get kind of tricky, but not too terribly tricky. They just need some practice. That looks good. We'll do a 5y plus 4 plus 3x times a 5y plus 4 minus 3x. Alright. So, sorry, my cat meowed at me. So what we're going to use is well, first, notice how we've got this 5y plus 4. We can put some parentheses around it. Nothing wrong with that. 5y plus 4 plus 3x. And we have this 5y minus 4. I'm sorry, 5y plus 4 minus 3x. So we really have an a plus b times an a minus b. Well, we know that that's equal to an a squared minus a b squared. Perfect. So all we have to do to solve this problem is we have to figure out, first off, what a squared is. If a is equal to 5y plus 4, that means a squared has to be equal to 5y plus 4 squared, which is the same as 5y plus 4 times of 5y plus 4. And let's use the distributive property. Let's use FOIL. We'll do first 5y times 5y is equal to a 25y squared. Outside, 5y times 4 gives us a plus 20y. Inside, 4 times 5y gives us a plus 20y. And 4 times 4 is equal to 16. We'll go through and gather our like terms. 25y squared plus 40y plus 16, and that's equal to a squared. Well, we also need a b squared. We see that b is equal to 3x. Go through and square both sides. That tells us that b squared is equal to a 9x squared. So, our final step is to put the information where it goes. We know that 5y plus 4 plus 3x times 5y plus 4 minus 3x is equal to a squared. 25y squared plus 40y plus 16 minus b squared, 9x squared. I believe I said 40y and wrote 4y. We were just copying this down there. Or we could have gone through and we could have used FOIL. I want to show you the distributive property with something that isn't a binomial. So there's our answer, 25y squared plus 40y plus 16 minus 9x squared. And let's tackle this problem a little differently. Let's say we had 5y plus 4 plus 3x times 5y plus 4 minus 3x. And in fact, yeah, I've got plenty of space. Let's work this on the back. 5y plus 4 plus 3x times 5y plus 4 minus 3x. And instead of doing an a plus b and an a minus b, let's just use the distributive property. We'll go, hey Hooper. Well, we'll take our first term, 5y, and we're going to multiply it into 5y to give us a 25y squared. Then we're going to multiply 5y times 4 to give us a plus 20y. And then we'll do 5y minus 3x to give us a negative 15xy. Doesn't matter the order you write these variables. You could have called it negative 15yx. It's kind of a convention to order your variables x, y, z. It's just a convention though. Doesn't matter. So we have taken care of 5y. Now we move on to the 4. Well, 4 is going to go on is going to get multiplied in by 5y to give us a plus 20y. 4 times a positive 4 is plus 16. And then 4 times a negative 3x is a negative 12x. The final step is to take the 3x. I did a circle, I did a square, so let's do a triangle, I suppose. 3x is going to get multiplied into the 5y to give us a plus 15y. 3x is also going to get multiplied into the 4 to give us a plus 12x. And then lastly, 3x is going to get multiplied by a negative 3x to give us a negative 9x squared. Now that we've gone through and done this, our final step is to gather like terms. I've got a 25y squared, and I don't see any other y squareds. I've got a 20y and another 20y, and what appears to be a 15y. That would give us a plus 55y. 20, 40, 55. Oh, we have a positive 12x and a negative 12x. Those are going to cancel. We've got a negative 15xy. And then minus a 9x squared. Let's figure out where we had 40y plus 16 minus 9x. Let's see, but I have clearly made a mistake because these two answers should be the same. It's good to go back and always check your work if you've made a mistake as compared to just restarting from the beginning, especially when you realize that you have recorded 2 examples in one take instead of just one. Oh, and so we did 5y times 5y to give us a 20y squared, 5y times 4, 25y squared, 5y times 4 for a 20y, 5y times negative 3x, negative 15xy, 4 times 5y is 20y, 4 times 4y is 16, 4 times negative 3x is negative 12, 3x times 5y is a 15xy. There we go. Made my mistake right here. Should have been 15xy. So let's go through and gather our like terms one final time. We still have 25y squared. We have a 20y and another 20y to give us the plus 40y we were expecting. We have a negative 15xy and a positive 15xy. Those are going to cancel out for no xy. We still have a positive 16 minus a 9x squared. 40y plus 16 minus 9x squared. Perfect. So we found our mistake. Be careful on these longer problems. It's really easy to make a little mistake. Go through and check your work. If you're having difficulties with these, let me know. I can give you some more problems if you need some more practice. I'm always willing to give you guys more problems. I'm just kind of hesitant to give you too many problems. So let's do one more example of these bigger ones since I did mess up, and I want to give you something that's smooth all the way through. So let's say we had an x plus a y minus a 3 times an x plus a y plus a 3. So I just made it up. I want to show you this motion again. So we'll take our first term and we'll multiply it into every term in the second factor. X times x gives us an x squared. X times y gives us a plus xy. X times 3 gives us a plus 3x. We then move on. Y times x gives us a plus xy. Y times y gives us a plus y squared. Y times 3 gives us a plus 3y. Then we move on. Negative 3 times x gives us a, well, we can fit it over here, negative 3x. Negative 3 times y is a negative 3y. And negative 3 times positive 3 is a negative 9. Go through and gather like terms. We've got an x squared. Oh, we've got no more x squareds. Oh, we've got an xy and another xy for a plus 2xy. And then we have a, let's see, we've got a positive 3y and a negative 3y. Those are going to cancel each other out. And we've got a 3x and a negative 3x. Those are going to cancel each other out. We have this plus a y squared. And we have the negative 9 floating around at the end. So we did first times middle, first times last, middle times first, middle times middle, middle times last times first, last times middle, last times last. I was going to write out a big acronym as kind of a joke. I think it would just kind of muddy up the page. You could also solve this problem like we tried to, or like we did on the previous example, as an a minus a b and an a plus a b kind of problem. Whether the formula or the process, whichever you choose, really, you could either use the closed form of the formula or you can go through the process. They will get you to the same answer. But like I said, just be careful. It's easy to make a mistake when you get going fast. So I got 2 more examples for you. One more of what we've been doing, and then we'll shift gears to something else. Let's say we have a, I hate it when they use s's, so we'll call this x minus 5y, x plus 5y, and then we'll call this an x squared minus 25y squared. And what we want to do is we want to multiply. We want to multiply and simplify. But now we're multiplying 3 things together. Multiplication, you can use the associative property with multiplication. What do I mean by that? That means that if you have a times b times c, that's the same thing as if you multiply a and b together and then multiply it by c. Or you could multiply a by the product of b and c. The choice is yours. You could also use the commutative property and rearrange them. It's kind of like a choose-your-own-adventure book, really. But I'm going to use the associative property on these first 2 factors first. So x minus 5y times an x plus a 5y. Well, if we use our distributive property, we'll first notice that this is an a minus a b times an a plus a b. Well, I already wrote it out, so we'll continue with this. We know that a minus b times a plus b is equal to an a squared minus a b squared. We see that x is equal to a. That means x squared has to be equal to a squared. And we see that 5y is equal to b. That means 25y squared is equal to b squared. So x minus 5y times x plus 5 is equal to a squared, or x squared minus b squared, 25y squared. So we can substitute this binomial in for the product of those two binomials. Or we've seen that x minus 5y times x plus 5y times x squared minus 25y squared is equal to x squared minus 25y squared times another x squared minus 25y squared, which is a minus b times an a minus b. Well, from before, we know that a minus b times a minus b is equal to an a squared minus 2ab plus b squared. We see that a is equal to x squared. That means a squared is equal to x to the fourth. A times b, well, that's going to be equal to x squared times a times b, over here, a times b, that's going to be x squared times 25y squared, which is equal to a 25x squared y squared, and we need a b squared. Well, b is 25y squared, so that means that b squared is equal to, 25 times 25, 5, 10, 12, 0, 0, 5, 625. I think I knew that. Is equal to 625y to the fourth. So we have all the pieces that we need. We just have to fill them out where they go. I have ran out of space, so I am going to copy this formula, or how about we do it like that? So we know that over here, x squared minus 25y squared times an x squared minus 25y squared is equal to an a squared, which is an x to the fourth, minus 2 times ab, which is 25x squared y squared, plus b squared, plus 625y to the fourth. The final step is to simplify to get an x to the fourth minus 50 x squared y squared plus 625y to the fourth for our final answer. The thing was, you could multiply in any order you want to. We multiplied these two together first because we saw that we had an a minus b and an a plus b. We have a nice closed form formula for that, so we used the formula. And that got us to this step. And then we notice we have an a minus b times an a minus b. Okay, so we used the formula to fill it out again. You could have, if you didn't want to use the formulas, you would just pick two, multiply them together first, and then multiply the remaining two together at the very end. Wouldn't matter if you multiplied those together first, or those together first, or those together first. You just have to pick two and multiply them together first. So, one final example for you. Shifting gears, getting away from what we have been doing. So, for now, we're going to talk about function notation. Specifically, we'll talk about the function f of x being equal to x squared minus 4x plus 5. And something, well, first, let's have a refresh. I know we talked about evaluating polynomials, and this is just a polynomial in the last section. But if we wanted to plug a number in, well, anywhere that there's an x, we'll replace with that number. And then we can simplify. 3 squared is 9, minus 12 plus 5. Negative 3 plus 5 is equal to a positive 2. So we can plug numbers into functions. Let's plug an expression into a function. Let's say we wanted to know what f of a plus 3 was. Well, just like how we replaced every x with 3 in this example, we'll replace every x with an a plus 3 in this example. Perfect. Now we still want to we're going to use a distributive property. It's going to be equal to an a plus 3 times an a plus 3 minus a 4 times an a plus 3 plus 5. And I know I jumped from lowercase to capital. They're the same a, believe me. First, a times a, and I can jump back to lowercase, a squared. A times 3 is plus 3a. A times 3 is plus 3a. 3 times 3 is plus 9. Then we'll distribute some more. Negative 4 times a is a minus 4a. Negative 4 times 3 is a negative 12. I'll warn you, if students make mistakes, they're going to make a mistake right here. Remember that this minus sign is attached to that 4. A lot of times students will correctly multiply negative 4 times a to get a negative 4a, but when they return back, they only grab the 4, and they would say that that's a positive 12. So just be careful when you're using your distributive property. And then that plus 5 drops down. Final step is to gather like terms. We've got an a squared. We've got 6 a's minus 4 a's, which would give us plus 2a, 3, 6, 2. And then negative 3 or 9, take away 12 is negative 3, plus 5 is going to be a plus 2. So we've got a squared plus 2a plus 2. So it's okay, our function isn't going to give us a number. It's going to give us a brand new polynomial, and that's what you're expecting in these. So the final thing, we start off with numbers, we're plugging in expressions. What we're going to do is, for now, it's just going to be an algebraic exercise. If you continue on through mathematics, they'll start to give this thing we're about to do a name. In college algebra, they call it a difference quotient. In calculus, you'll use some more tools with the thing we're about to talk about, and you'll get a derivative. So even though for now, just evaluating f of a plus h minus f of a might seem like a tedious exercise, and we can be honest here, it can feel that way sometimes. This will come back in every math class up through calculus. It'll look a little bit differently. Eventually you'll divide by an h and do something out front, but this sort of algebraic exercise doesn't go away. So let's evaluate f of a plus h minus f of a with this function. It has two parts. It has this first part. Oops. It has that first part, and it has that second part. So for the first part, f of a plus h. Well, we're still using this function, so we would get a plus h squared minus 4 times a plus h plus 5. And we'll go through and we'll simplify. A plus h minus 4, a plus h plus 5. Well, we'll use our distributive property. First, we get an a squared, outside plus ah, inside plus ah, last plus h squared. Then we'll distribute. Minus 4 times a is negative 4a. Negative 4 times h is negative 4h. And then plus 5. You always want to simplify. You always want to gather your like terms. So we get an a squared plus 2ah plus an h squared minus 4a minus 4h plus 5. And then we will put an asterisk next to that because we're going to use it again. So that's our first part. And we have this f of a. So f of a, going back up to this original function, is equal to an a squared minus 4a plus 5. Perfect. So we have both of our parts. We know what f of a plus h is. We know what f of a is. So the final step, f of a plus h minus f of a, well, that's going to be equal to f of a plus h, a squared plus 2ah plus h squared minus 4a minus 4h plus 5, f of a plus h, and then we want to subtract f of a squared minus 4a plus 5. Be careful because you need these parentheses. We are subtracting all of f of a, so we have to make sure that all of f of a gets in parentheses. We're going to simplify. I only put these parentheses here to draw your eyes to them. A squared plus 2ah plus h squared minus 4a minus 4h plus 5. And then we're going to subtract an a squared. Then we're going to subtract a negative 4a, and we're going to add 4a, and then we're going to subtract a 5. All of these problems, we're going to get, the final step is to gather our like terms. I've got a plus 5 and a minus 5. I've got a plus a squared and a minus a squared. And I've got a minus 4a and a plus 4a. So when we gather our like terms, we're left with the 2ah plus h squared minus 4h for our final answer. Like I said, for now, this is really just an algebraic exercise. You guys just, well, not necessarily just, we just had the lecture discussing how to deal with squaring a binomial, and then multiplying leading coefficients into a binomial. So for now, and we were evaluating polynomials like we were last section, so it makes sense to be here. But go forward knowing that this is an algebraic exercise. This is important. I'll promise you that I'll have you do this on a quiz. I'll probably have you do this on a test. I've asked almost all my classes to do this on a test because we cover it in just about every class I teach. But in closing, that's this lesson. We started off. We were really talking about the distributive property the entire time. When we were multiplying, let me gather my pages real quick. It started off with multiplying monomials together. When we multiply monomials together, we're just combining like terms. Combining like terms. When we use the distributive property is when we have multiplication and subtraction, or when we have multiplication and addition in the same problem. This problem just had multiplication. This one has subtraction. So as soon as we have a mix of operations, that's when you use a distributive property. I always thought of the distributive property kind of like a crane operator. They go and pick up the first and drop it on the second, and pick up the first and drop it on the first, and pick up the first and drop it on the second. It all boils down to combining like terms. And then we had some special formulas. We talked about this a plus b and this a minus b, and we came up with these nice closed formulas. A plus b squared and a minus b squared. It was these three. 1, 2, 3 are our three new formulas. One second. Oops, that's a plus. There we go. This lowercase a is the same as that capital A. I'm sorry, I warned you about it in the beginning. I'm going to switch between the two pretty often. I'm sorry. Should be capital A. But these are our three new formulas. You don't have to use them. You can always use a distributive property. You can always use FOIL or some variation of FOIL to solve these problems. But like I said, next lecture, instead of going this direction, we're going to be going this direction. So working with these formulas will help you go the other direction. And the last thing that we did is this big algebraic exercise, as I keep on calling it. Being able to take a function, f of x being equal to this polynomial, and plug in an expression, like a plus 3, or like a plus h. The big stuff, and like I said, I will ask you to do this entire process on a quiz and probably your test, is being able to find, well, what is f of a plus h? What is f of a? And what happens when I subtract the two? Being careful, because you need to subtract the entire quantity. That wraps it up for this lecture. Some homework for you. Go and do 7 through 27 every other odd. Go and do 37 through 53 every other odd. Go off and do 63 through 79 every other odd. And 85 and 87. Sorry this lecture or that homework set got a little bit long. We honestly covered a lot of material. Next time, or on Thursday or Wednesday, you guys will have a quiz. Expect just chapter 4 material on it. Be ready to add polynomials, subtract polynomials, gather like terms. Be ready to multiply some polynomials together, showing all your work. And make sure you do your homework. Yeah, let me know if you guys have any questions. There's a lot of good online resources. Shameless plug to wolframalpha.com. If you're getting stuck on these, if you need something to check your work, there's a lot of online resources that will simply show you the answer. And that'll let you know if you're doing these correctly. If you guys want answers from the back of the book, let me know, and I'm happy to provide you guys with answer keys. And if you feel like you need more practice in any one section, let me know. I'm happy to talk about it with you, figure out where the issue might be, and get you the help that you need. I can give you more homework sets. We can try and set up a Zoom meeting if that would help you. Whatever you guys need, let me know. I'm still here to help you. Go off and do that homework for Wednesday. Have a nice day, everyone. Bye-bye.